Good afternoon, everyone. I promise you we'll get to lunch soon enough. Don't panic. You're probably all hungry. Thanks for coming. I'm going to talk to you about content security policies. We're going to break some stuff. It's part talk, part therapy, part confessional. You'll see why later on. Clicker, work. There we go. Really quick about me, because you all really care about this stuff. I'm a senior software engineer at a company called Viva IT. If you've ever been to Symphony Live or PHP Northwest, we'll be in orange hoodies. Come and say hello to us. We're quite friendly. At Brunt on Twitter, if you want to leave me feedback or whatever. I also organise PHP's Midlands in Leicester. My website and my email, you don't care about that because no one does that any day. So, get on with the talk, Matt. Get on with the talk. Here's some things I do. I Dungeon Master in Dungeons & Dragons games. Another cheer, third time in a row. That's a win for that one. I mentor, I lead, and I teach apprentices and junior developers, both in the community and at work. I run and organise PHP's Midlands, and apparently talk to epic music in the other channel. I speak at user groups and conferences, such as this, and I break production with badly configured content security policies. Yeah. So this is a talk in 3 parts. We're going to cover some cross-site scripting. We'll show you the scary stuff first. Then I'll talk about content security policies, how they can help us. And then we'll break some stuff, and you'll see why they can be bad as well as good. So let's start with the scary part. Who here knows what cross-site scripting is? Cool. Effectively, it enables an attacker to inject scripts into non-malicious web pages, and that'll be important later on. In 2016, as part of one of the research papers I was looking at, there was a 61% likelihood of a browser-based vulnerability in a web application. And of those, 86% were found to be cross-site scripting related. So that works out at just over 52% of all the vulnerabilities they found were cross-site scripting related. It's kind of scary when you think of the number of websites and the number of attacks there are every single day, even the ones you don't hear about. You hear about the big ones that Troy Hunt goes on about and loads data into having been pwned from various exploits. A lot of them start at a very basic level with cross-site scripting. But it's just a joke vulnerability. That's how people see it. Then it's just, what can you do with it? I put some pictures of cats on someone's webpage. I can alert a poop emoji and really annoy people. I can rickroll a user. I can have a self-retweeting tweet. Who encountered that one? There was a vulnerability in TweetDeck where someone managed to inject scripts into their tweet, and anytime it appeared on someone's timeline, it would retweet itself onto their timeline. And then, yeah, you see how this goes. Who encountered the Sammy worm back in MySpace days, when MySpace was still a thing? This was someone who set up a profile on MySpace, put a little bit of code on the page so that when you visited the page, it would send him a friend request automatically and accept it, and then add that same code to your profile page. And then anytime someone went to your profile page, they sent him a friend request, and it accepted it, and added it to their page. And I think he got up to about 1 million friends in about 24 hours with this. It's a joke, 3 years probation, not allowed near a computer. It's not really a joke, because you can make modifications to the DOM. Replace form actions to point to your website instead of where they expect it to go. Wouldn't it be great if your bank form to transfer money to someone else's account sent it to you instead? I've hacked, Mr. Smith over there, and now he's sending all his money to him and he thinks he's paying rent. I can use XML HTTP requests to make asynchronous requests in the background, fetch me additional resources that I might need. I can access HTML5 APIs. With browsers, you can now get webcam access, microphone access, geolocation access. I can steal your cookies if they're not set up properly. And therefore, I can steal your session cookies. And because of that, I can log in as you on another website. The HTML5 APIs one's quite scary, because if you've ever enabled them on a website, you get an option like this. I'm going to always allow this site to use my camera. I trust it, non-malicious. Hacker comes along and updates supercats.com to point to their site, and suddenly you talking to that cat through an API. It's not really talking to them anymore. But this is how people think, yeah, it's just a silly little thing you can do, but it's really not. Back in 2008, there was an epilepsy support forum that got hacked. Cross-site scripting vulnerability. They injected code into a form that posted hundreds and hundreds and hundreds of legitimate-looking forum replies. When people, often who were suffering with epilepsy, would click on them, full screen, flashing colors, flashing shapes, flashing images. Physical damage was done to people. One lady had a report that she sat and had a seizure at her computer until her son pushed her away. So cross-site scripting is not really a joke. There's a few different types. We have type 1, known as stored cross-site scripting. Basically, it occurs when input is stored somewhere, usually in a database on the server, but with more modern technologies, there's things like HTML5 databases. You've got local storage, which is a browser-based storage engine you can use on the front end. So it doesn't even have to, the payload doesn't even have to reach your server for it to be vulnerable. Another one was Whois is a website that someone rickrolled with a TXT record on their domain. They put in the iframe code for Rick Astley's video in one of their TXT records. Whois was pulling that data from somewhere and just trusting that, oh, if I'm scanning DNS records, they're safe, right? That got fixed quite quickly, but that was a legitimately real thing. And I wish I'd have thought of it first, because that was great. There's type 2 cross-site scripting, which is known as reflected. It's non-persistent. The data doesn't get persisted anywhere. Basically, data is reflected back to the user when they make a request. So they make a request for something, it might be like in a search string. You'll often see that search string come back in the response as a URL, and they might output it on the page to say, hey, you searched for supercats. So because it's not stored, it also might not even reach the server. It might just be a pure browser-based attack, which is known as DOM-based cross-site scripting. It's called Type 0. It's a more modern one with the sort of rise of single-page applications and lots more front-end frameworks and lots more logic being done by JavaScript in the browser rather than the server. It's a new type of cross-site scripting. So it takes place completely within the browser. If JavaScript takes input and then uses document.write to write it back out to the browser, potentially you're vulnerable to DOM-based cross-site scripting. There is a fourth type. It's called self cross-site scripting. It's social engineering, because if you can socially engineer someone to do something for you, you can get them to execute code in the browser. So if you've ever opened up the console and, hey, just go onto this site, open up this little console, which is a magic thing that you don't know about, but if you put in this code, you can get access to all your friends' Facebook messages. That type of attack. Because you're doing it via the console, you can't necessarily protect against a lot of that stuff, because in a browser, the console has an elevated level of privilege. It's kind of more of a, well, if they're putting stuff in on the console, they probably know what they're doing. So you can't protect against a lot of things with that. Some don't consider it to be a true cross-site scripting attack because you're asking the user to do it for you. But at the same time, it's still a valid form of attack. If you phone up a company and get onto one of their sysadmins, hey, can you just log onto the server and run this command for me? Fantastic. Yeah, no, we're just a support company. It's OK. You can trust us. You've still technically breached them. You haven't. People throw the word hack around for any number of reasons, but you've got into their systems, whether it's through port scanning and finding vulnerabilities in software or phoning up the sysadmin and asking them to run the command for you. Both are valid. Who here has opened up the console on a site like Facebook.com before? You seen this? Facebook puts a nice big warning on there saying, don't paste code in here. They've told you can hack your friends' accounts. Bad things are going to happen. So you can't stop them pasting in. You can't do that. But if they ignore it after a warning like that, what can you do? You can make it as big and red as you want, but So there's some quite scary things we can do with cross-site scripting. And so we need to fight back against the hackers. And we can see that this person is a hacker, and we know for 3 reasons. 1, hood is up, okay? Trademark stereotype number 1 for a hacker. 2, claw-like fingers on the keyboard. 3, hunched position, okay? They're also a member of Hydra, which makes this extra bad, okay? So we have to stop this. That's my friend Froggy. I've actually asked permission to use that photo. So we need to fight back against these people. These are the ones we're going after, the hoodie-wearing, hunched, claw-fingered hackers. At a very basic level, a content security policy is just a response header to help reduce cross-site scripting risks. Note, it doesn't say fix cross-site scripting problems. There is no silver bullet, we're not fighting werewolves. It's to help reduce the chance that a risk will be found and exploited. Like anything in security, there is no one solution fits all. There is no answer that fixes everything for everyone. You have to put more layers in place. You have to just put more systems in place to make it more difficult and reduce the risk. There is no fix. Anyone who says they are fully secure is lying to you, and you can tell them that. Basically, a content security policy works by declaring what resources are allowed to load. Browsers are stupid. If you load a web page and it's got a script tag in there that says, hey, load superhack.js from mybadsite.com, the browser will be like, okay, I've got this. You've asked me, I fulfill your request. And it goes away and loads that script and terrible things happen. The way a cross-site content security policy works to reduce that risk is when you send a response back to the browser, you send a header along with it. And you say, I only want scripts, styles, images, fonts, objects, various other things to come from these trusted places. If mybadsite.com is not listed as a trusted place, which probably shouldn't be, it won't get loaded. The browser will say, aha, I'm smart this time. You've asked me to load that script, but you also didn't tell me I'm allowed to. So, sorry, it's not going to happen. So because of this, we need browser support, which, for anyone who's going to ask the question at the end, I'm sorry, IE6 is not supported. Every time I get asked that question, I'm sorry. Also, I'm sorry you still have to deal with IE6. You have my condolences. There are a couple of levels of content security policies. We do have a Microsoft product supporting it in Edge, which is cool. IE doesn't really anymore. Chrome and Firefox have supported it for quite a long time. Safari supports the new version as of version 10+. So if you're using Chrome or Firefox, you've got this, you'll be fine. Safari, if you're using an older version, you've got level 1, which is the initial version of content security policies. Otherwise, you've got version 2. IE, sorry. Edge, you're doing okay. If you're on a modern version, you should be okay with this. So we can protect quite a lot of things with a content security policy. Default source is something that acts as a fallback. So if you don't specify a more defined and specific source to work with, a script or a style, it will fall back to default sources. Like, well, you didn't tell me that I could load the script from there, or you didn't declare a script directive. I'm going to fall back to default source and see if it allows me to do it. We can protect against scripts, styles, which is quite cool, images, which is also quite cool, form actions. So you can say, I only want forms to be able to submit to these locations as well. So as I mentioned earlier, if someone gets onto your bank and changes your send payment form to point to their website, with a content security policy and a browser that supports it, it wouldn't go through. The browser would not submit that form data to that location. And here's another one for you. Who here has had the joy of upgrading a site from HTTP to HTTPS across the board? Keep your hands up. Who's done that on a CMS website where clients have put HTTP like images and that in the WYSIWYG editors all over the place? Yeah. Who went, oh, now I've got to replace everything in the WYSIWYG, in the database to go and point to HTTPS because mixed content warnings and Chrome's going to complain. Content security policies have another magic option called upgrade in secure requests, which if it finds a resource that's loaded over HTTP, it will automatically upgrade the request before it's requested to HTTPS. It still has to be available over HTTPS. This doesn't break web encryption. It still has to be available on a secure connection. But the browser in the background will just sort of invisibly upgrade that request to the secure version, which is really quite handy. It can help you catch all those edge cases that you've missed. There is a full reference online, because there is way too much to go through in like 50 minutes. Content-security-policy.com has got everything. Also, the Mozilla Developer Network has phenomenal resources on this. If you're still using W3 Schools, download the Chrome extension that removes it from your search results. And any front-end based query that you type, just add MDN after it, and you'll get onto the Mozilla Developer Network, which is one of the best resources out there. I'm not a front-end person. This is kind of the front-end stuff that I do, but that resource is just phenomenal for everything. So let's look at how we can implement some of the things that I've gone through. Image source star. It acts as a wildcard. So any URL you give on a page of an image, it will load. It doesn't allow data, blob, or file system schemes. So if you've got data URIs, you say you've got a base64 encoded SVG that you've put on the web page as a data URI, that wouldn't be allowed. That wouldn't be allowed. You would have to allow that explicitly. But otherwise, any URL, I don't care where you load images from, they can come from anywhere. You might say object source none, and that basically says don't load it from anywhere. I want to block everything on this directive. Don't load any objects from anywhere. Style source self says, okay, as long as the thing is being requested on the same host, scheme, and port that I'm on, I'm okay with this thing loading. Unsafe inline allows the use of inline source elements. So if you've got an inline script in your template, or you've got on-click attributes on HTML elements, you can use this. Who's still got inline scripts on their web pages? Don't use it. There's a keyword here. It's in big letters there. Unsafe inline effectively says any script that is on the page I will execute, even if it's inline. And that's often where a lot of the kind of XSS vulnerabilities come, in that they inject scripts inline to the page. Don't use it. Excuse me. If you do need to use inline scripts in your templates, say you've got a CMS website and you allow people to dynamically populate images that needs to have a carousel, and you need to be able to supply that data, and you've got this script that does that, and you're like, I could move it to an external script, but it's a bit too difficult, or you just can't see a way of doing it, and you need to keep that inline script in your page. You can use what's called a cryptographic nonce. It's a number that's used once. And what you do, as part of the header, you specify nonce and a random string. Don't use $random. That's not random. That's substitute random value, okay? So you generate a random value on that request. And in the response, you send that value back as part of the header. And then in your script tag, you put that same value as a nonce attribute. And the browser goes, right, well, this is an inline script tag. You might have blocked that, but it's got a nonce attribute with a value that matches the header. So I trust the headers that are coming back. Another question I get asked is, what if someone could manipulate the headers? And my thing is, well, you can't protect against that. You've got other problems. But the thing that's set in the headers in your application should be trustworthy. So if these two numbers match, it will go, okay, I trust that this could only have been added by the application itself, and it's a trusted source. I can execute what's in this script tag. So you can keep your inline scripts by adding this sort of thing into your application. A more full policy might look a little bit like this. I've got a default source of none, so my fallback is don't load anything. I've got a script source of self, so load scripts as long as they're from myself, or https star.google.com, so any Google subdomain over HTTPS is allowed to load scripts on my website. Who uses like Google Analytics and whatnot on their site and has scripts from Google? Congratulations, you're vulnerable to cross-site scripting. Yay. You've consented to it as well because you've put it on there. I can't remember who said it, but effectively, linking external scripts on your site, such as Google Analytics, is consensual cross-site scripting, because you've said, hey, I'm going to allow you to run scripts on my website. We then got a nonce here of random123 again. Example, don't use random123. Do as I say, not as I do. Style source of self, load styles from myself. Image source of self, load images from myself. I want you to upgrade in secure requests because I maybe have a few leftover HTTP images in some WYSIWYG field somewhere. And I'm only going to allow you to submit forms to myself, basically. So if someone manages to replace a form tag, it's not going to work if it points to their site. So now's the point where I sit down in front of you all and I make an honest statement. Hi, I'm Matt. I broke production. And I'm here to help you learn from my mistakes. Okay, clean conscience. Right, don't do what I did. I thought I knew it all. I implemented a content security policy, deployed it, went, yeah, I'm cool. Boss, site's secure now, we're okay. About 20 minutes later, the phone rang. Why is the website not working? You're gonna have to give me more information than that. Well, it's broken. What does broken mean? It's broken. Okay. Looked at it, works on my machine. ticket closed. Don't do that, okay? I'm an idiot. The problem was that because it's a browser-based thing, my browser was doing something different to potentially theirs, and they had extensions installed and other bits and pieces that were going wrong for them. And that's when I sort of went back onto the documentation, and I did a little bit more reading, and I'm like, I feel guilty for closing that ticket. Maybe they were right. Okay, take a step back. The boss might have been shouting at me as well. So I went back and I looked at it, and I discovered there was this amazing option called Report URI. And what this does is it says, right, when a policy failure occurs, send a payload to that URL. And what that JSON payload contains is, here's what went wrong. You get some nice debug information of, okay, so I've got what was blocked, the blocked URI. I've redacted a lot of this. Like what line number it occurred on, what policy was violated. So this was the script source was violated. And there's quite an interesting little word there on this. So this is a sample of the script that broke the website. It turns out at that point in time, LastPass, the way their password manager worked, is the extension would inject scripts onto the web page to get it to replace stuff. And my content policy went, no. Amongst other things, this was one of the things that went wrong. But that's, when I learned about this, I was like, okay, this is cool. Because the problem I had was them telling me it's gone wrong meant that I had no more information because, you know, you take your car to the mechanic and go, fix it, bye. And then you walk away. That's what the client had just done to me. So, okay, I thought, right, I can get a payload sent somewhere, but I've now got to, I've got to write something in my application that captures these payloads, and then I can report on them, and I can like log them and have some maybe some analytics. And then I came across a website called reporturi.io, which is written by a fellow called Scott Helm. I've spoken to him quite a lot about content security policies, and he's given me so much of his time. But he really knows his stuff. And he wrote this website that said, hey, we'll give you an endpoint to send stuff to, we'll give you charts, we'll give you reports, it's all free, have fun. Hey, boss, I found this new thing, I don't have to do a week's worth of work. And who's heard of Troy Hunt? Just this week, Troy Hunt has now got on board with reporturi.io as well. Scott Helm is now working on it full time. It's free up to 10,000 reports every month. After that, you start paying per number of reports. Great service, though. And he's now working on it full time. Troy Hunt's on board and supporting that as well. So there's a fairly big name behind it as well. But this now gives me a place where I can configure my policy to send these violations to that endpoint and be like, here's what went wrong. And I can start debugging that information. Reopen ticket. Okay, maybe it's not, can't replicate. But you get kind of outputs such as this. It'll tell you the directive that was violated, the blocked URI. It will give you the raw report if you want to. It tells you what browser did it as well, which is quite nice. You can get charts and outputs and look at it over days and hours and see how things have increased or decreased. And that's really quite nice. There was a problem with this, though, is that I was getting information that it was wrong, which is really cool, but it was still wrong. The site was still broken for the users. It wasn't working. And then I discovered another thing that I thought I knew all about, but I didn't. And that was a thing called report-only mode, which works the same as a content security policy. But when a violation occurs, it doesn't enforce it. So if a script or a style tag is not meant to load, it won't block it from loading. It will allow it to load, but then it will still send you a policy failure payload to be like, hey, this would have broken. Rejoice. So I was now being able to get information from the users, from the browsers, as to what was broken, but things weren't breaking, and I could fix it. Everyone was a little bit happier. I'm still running around like a headless chicken trying to fix it, but clients weren't as angry. It looks pretty much just the same as a normal content security policy, except you now have a report only on the end of it. Put your normal policy in, and then at the end you specify report URI app, and then that's a report URI URL that it will give you to report to. Similarly, if you do want to report on enforced payloads as well, same sort of thing, just on a normal content security policy header. The important thing that this allows you to do is it allows you to trial stuff before you enforced it. We now test our content security policies properly in our CI system. Lesson learned. But because it allows you to trial stuff, it allows you to kind of go, okay, maybe I've got a policy in place already. And I know it's kind of working, but I want to maybe restrict it a bit more or be a bit more strict to increase the security of it. I can now add a report-only header as well as my regular header, and then one will be enforced and one will be reported on. So I can have my current policy in place that I know works, put that in place. Okay, I want to change it. Rather than just change it and then hope nothing breaks again, because, learn from your mistakes, Matt. I can put a new one in that's report-only and capture the reports from that one and say, right, I can make sure that nothing's going to go wrong, keep an eye on it. When I'm comfortable that everything's going to be okay, I can then move it to an enforced policy and carry on. You need to be careful with this because there will be lots and lots and lots of noise. Now, when I first set up the report-only policy, I set it up, and within like an hour, I had like 10,000 reports. Like, hey, here's everything that went wrong. Oh, no. So you've got to work through this iteratively. You've got to kind of try not to look at everything, pick specific things, fix them, and watch the numbers go down gradually. You've got to filter through the noise because that will just block you from, you'll freeze and there'll be, oh, it's too much to fix, I can't do it, take it away and just don't bother. Take it slow, work through it, put something in report-only mode, be less restrictive maybe, and then gradually get more restrictive over time. I went the opposite route and went, I'm going to be really secure and I'm going to restrict everything and then allow things. That went wrong. Another thing that you need to do when you're working with this, you need to make it easy for people to use. So this is one that was learned from experience. Have a quick way to disable it in production. Even better, have a way to switch it to report only instead. So rather than just disabling it and getting nothing, switch it to report only mode because then you can actually start getting the logs. That's an even better way to do it. Add the CSP at an application level if you need a cryptographic nonce. You can add cryptographic nonces in Nginx. I've seen the configuration for it. It's hell. And then I don't know how you get that back in your application to use in templates. Not quite sure. So just use some sort of generator. Middlewares work really nice for this in lots of modern applications if you've got PSR7 stuff. So just add it at an application level. Cryptographic nonces, ways to remove barriers in development with this. Don't generate multiple nonces in the same request. It has to be used once per request. But you do need to generate a new one on every single request, otherwise they kind of become useless. Because you can start guessing the exact same thing that's going to come back on every request, and attackers will know that. Ooh. If you're using a templating engine, such as Twig, Blade, whatever, add it as a global variable to the templating engine that's available to you. That way, you don't have the excuse of developers going, I would have added the nonce in, but I've got to put it in my controller and then assign it to the template, and that's just more work. If you add it as a global variable, so it's available in every template that's ever rendered, that'll just make it a lot easier for everyone. And then similarly, write a helper in your templating engine, write a macro, a function, an extension, or whatever, to be able to generate a script tag with the nonce automatically, so that people don't forget to add the nonce attribute onto the script tags that they might be putting in their templates. Again, these are just ways to remove the barriers to development, because all of these sorts of things, they're only as good if they're used. If they're not used, it becomes pointless, and developers will use any excuse not to use it because developers are lazy. Case in point. So, here's the fun part. Ooh, got a static shock. That's not a good start. Ow. We're going to break some stuff. Let me just switch over my displays. View. Presentation mode. There we go. Right, we have a small application that we've written. We're developers. And we've built a website for the Ellingson Mineral Company. If you've seen the talk before, don't answer, but 10 points to anyone who knows where it's from. No one's ever got this yet. No? It's the movie Hackers, the greatest film of all time. If you haven't seen Hackers, your homework is to go home and watch Hackers, okay? But we, as a collective, are a fairly large development team that got asked to build a very small website. They've got too much money, we'll take it, it's fine. Two of us can do the work, everyone else can go on holiday. So as we can see, the Ellington Mineral Company, they've got some business and marketing spiel. They've got an image here. They've got a page for their Gibson supercomputer, which is like the most amazing supercomputer in the world. And the marketing team came to us and they said, team, we need this page to be secure. we need to let the users know that this page is secure. And how are we going to do that? We're going to display a really annoying pop-up to let them know that the page is secured. Because if we don't pop it up in their face, they're never going to know that they can trust us with their data and the page is secure. So we say, OK, fine. And this is our supercomputer. Lights, towers, typical movie computer stuff. And we have a page where we can have secure files stored on the website. We can have notes in here. We update our note and we get a little message, hey, ScotlandPHP, nice to meet you. I'll make that a little bit bigger. So we can now see that this is our website and these are the features and functionality that we've got to have. So that's us as a development team. And then the hackers come along, which, OK, hood up, arched back, claw-like fingers. Hackers come along and they notice something on this website. And they say, OK, I can see up here in the URL, there's this little files updated message as part of the URL here. And I can see on the web page that I can see files updated on the page. So the next thing they'll do is, OK, fine, let's oh, hello, ScotlandPHP. I can have some fun with this now. As a hacker, they might come along and they'll start, OK, I've seen that there's potentially a vulnerability here. I'll probe a little bit further. I'll see what kind of levels I can escalate this to. And they come along and they say, OK, alert. Nope, script. And then we're going to alert. Let's do poop emoji. I'm just going to copy this for later. I say, OK, let's see what we can do with this. Oh, fantastic! I've got a poop emoji on the page, and that's the user that's clicked this URL. Now, the problem is that if they go back to this URL, they no more poop emoji. But that's because that, I'm going to take this hoodie off now, I'm getting a bit warm. That's a reflected cross-site scripting attack. The data isn't stored anywhere. We've sent it to the server, and the server sent it back as part of the response. So that's just reflected the content back at us. But then we do notice that they've got this nice notepad here where we can start putting content. And if we update content in here, and we update the note, I've got updated content. OK, so what if I alert poop emoji? Oh, fantastic. And I've got that on the page now. And when I go back to the page, fresh, it alerts poop emoji. And I go back to the page, and it alerts poop emoji. And I go back to the page, and it alerts poop emoji. But this, I've now looked at this, and I've gone, OK, that's now a stored cross-site scripting attack, which means that anyone visiting this page who has that content sent back to them is going to have that same vulnerability. Now, in this example, I've just put a poop emoji in. I could do something a whole lot more damaging, but the basic concept is there. We've found that there is a cross-site scripting vulnerability in the application. There's a few caveats to this from a technical level, so let me just give the disclaimer. Browsers these days implement a lot of cross-site scripting protection in the browser itself. If they detect script tags coming into the website, they will block them and do various things with them. If you've got a WYSIWYG editor and that kind of thing, and you're allowing users to put in their own content like that, you might have to disable that. You need to know what you're doing to do that. There is a header that you can use to disable that protection, and as it says here, don't do this, because bad things can happen. I'm doing it because I don't really know what I'm doing, but I'm acting like I do. So I'm allowed to. And in our content pages, so if I look at, oh, no, I'm going to want to go to garbage files. I'm outputting raw content. That's generally not a good thing to do anyway. Your templating languages should escape it. Again, demonstration purposes, do as I say, not as I do. So we come along. No, wrong way, go away. Keybinds, what are you doing? Right, in our application, we as developers then go, aha, no, I can fix this. I've heard of this amazing thing called a content security policy, and I'm going to add it into my website, and I'm going to fix these problems. I'm going to get these hackers. I'm going to fight back against that hooded Hydra agent who's trying to attack the website. So this CSP middleware, all it does is just add a header to the response as it's going out with a load of content that we can configure. If I look in here, I'm going to go to my default. We're going to say, I'm going to foil those hackers. They're not getting anything. Beat me now. Yeah. I win. And then the boss starts shouting at you. You're like, OK, fine. That's not good enough. If I go back to my home page, oh, maybe the home page worked? No, the home page doesn't work either. How are they going to know we're a professional company if they can't see our logo? How are they going to know our Gibson? There's no picture of our amazing supercomputer. This is a disaster. So we go, okay, right, we've got a few things we need to do now. We'll start adding things back in and making sure that things aren't quite as broken as they are right now. So we'll say, I'm going to allow styles from myself. If we go back to our browser, hey, I've got styles back. Wait. Yeah, I've got styles back. So I've basically said, right, as long as styles come from the same domain as myself, the CSS can now load. That's cool. I didn't put my colon in, that's why images were loading. But if I wanted to get images loading, image source, also self. As long as images are coming from myself, this is cool. I can allow images to load. We go back to our page. Fantastic. Homepage loads with our images. I've foiled the hackers because there is no more script running. And our Gibson page is showing our nice big picture of our computer. And then the marketing team come along and say, Matt, there's no message telling them that the page is secure. Our users don't trust us anymore because we're not forcing it upon them that we are a secure company. Okay, fine, I can get the script tag back, we can do that. Okay, script, source, unsafe, inline, yeah, that'll work. We'll get the script back. We go back into our browser. Page is secure. Marketing team are happy because the script is now executing. Homepage loads, we've got images, we've got CSS. All our users know that we are legitimately secure and the page is secure and they're happy. And in the garbage files, that's not any good. I've not really fixed the problem. I've not done anything. So we go, okay, there's potentially a problem here. So we look at our templates and we go back, okay, right, let's have a bit of a further look. If I look at the Gibson page, it's an inline script. There is no reason this could be moved to it couldn't be moved to an external script, but for the purposes of this, it can't be moved out of the template. So we say, okay, in order for this to work, I've heard about this thing called a cryptographic nonce that I can use as part of a content security policy. And I've got this, I'm using Twig as a templating language here, but I can now put this variable in, input the nonce into the template whenever it's added to the header. If I go back to my middleware, you can see that when I construct the middleware, I give it a cryptographic nonce to use, and it just does some very basic string replacement to put the nonce into the content security policy, wherever it finds curly brackets nonce. And then in my security file, I'm just going to undo some of this because it'll be quicker. Here, I've got style source, self, nonce. You can use nonces for styles as well if you need to do that sort of thing. And I've also got script source, self, and nonce. And this will now replace this curly brackets nonce value here with our cryptographic nonce that's come through into our CSP with nonce dash at the start and make it easier for us to use. So now we go back to the site and we say, okay, homepage, secure. That's working, we're okay with this. People are happy. Gibson, marketing are happy, we're nearly there. Page is secure. Garbage files, victory! There is no more poop emoji. The hackers have been defeated. We've thwarted them. We can go back to our startup culture of beer and bull pits and have a party. And those dastardly Hydra agents are not going to get hold of our secure files or our Gibson mainframe. Marketing's happy, we're happy. Management happy, no one's shouting. After this talk, if you want to learn more about this, go and follow Scott Helm on Twitter. He really, really knows his stuff. It's not me. I'm a different person. But he really knows what he's talking about with this. He's kind of like my go-to for keeping up to date with stuff. He runs Report URI, which is a website that gives you endpoints to capture content security policy violation reports. He also runs a website called securityheaders.io, which will scan your website and give you a nice little A to F rating of how good your security headers are, because there are a number of other things you can implement along with this. There's your homework. That'll be in the slides, that'll be online. There's a lot of pretty good content on some of these. OWASP top 10, cross-site scripting's still there. It's still one of the top 10 vulnerabilities found in applications. All the Mozilla developer stuff. The code for the demo is online on GitHub if you want to go and look at it. Thank you very much for listening to me prattle on and confess my breaking production sins to you today. Thank you. If you do want to leave feedback, joined in there. If you do take a sticker, you've agreed to leave feedback. If you don't, the stickers are cursed, and whatever device you put it on will break within the week, okay? I had a picture of someone's phone that shattered. Wasn't really my fault, but I told him it was cursed. He didn't leave feedback. Does anyone have any questions? Yes, we've got a couple over here.
Keep your hand up.
Hello.
Hi. The reports URI place that you send all the reports to, does it collect any data about the person?
No, there is no PPI in it, so GDPR you don't have to worry about.
Fantastic.
Yeah, there's no IP address, it's browser stuff, and the actual report payload, it doesn't capture IP addresses and whatnot, so you're okay with that.
Cool.
Yeah. I made sure of that this week.
Hi, thanks for the great talk. I just had a question about your confession section.
Yep.
I would have thought that if LastPass got blocked, it would just break LastPass autofill.
It did. That was one of the number of problems that was occurring with this. I picked that out because it's quite an interesting example that a password manager was being blocked by security header.
Yeah.
There were other things that were being broken.
Right.
Yeah.
So with supplementary to that, there are a lot of extensions, I suppose, that inject scripts. How far would you go to support those? Or
a lot of them should be okay nowadays. The reason being is that browsers now say if this script, this extension needs to inject a script on the web page, it kind of bypasses the security policy because that script is added to the user's browser, and if the users add it to their browser, then it's kind of like a trust that they've added it for a reason. So they kind of bypass a lot of the security methods. So it can't protect against a malicious script that was added via an extension, for example, like has happened a few times recently with certain Chrome browser extensions. But that's because they're trusting that the user's adding legitimate things, and there's only so much they can do. So pretty much all extensions should now just be able to add whatever they want at the user's peril.
Thanks very much.
Anyone else? Yep.
So we've got the report feature for getting back data on stuff that's out in the wild.
Yep.
You mentioned you also do this sort of pre-deployment in your continuous integration stage.
Yeah.
What tools do you use to do that?
So we set up kind of the content security policy within an environment when we boot our application in CI. And we use a number of browser tools with Selenium to be able to load it in a browser and see what things are blocked via the console and whatnot. It's kind of a bit of a tricky thing to do. But after we broke it, we're like, we want to make sure that this isn't working. But there's some, like, if you boot up a browser with Selenium, you kind of have to do it in a real browser because it requires the browser support. So we boot it up in Selenium and then look at like console logs to see if I put this bit of content onto the web page on a known vulnerable page within a development environment, it should be blocked and I should see these messages kind of thing. So we kind of write assertions based on what console logs come out of the browser.
The other thing I wanted to ask was you mentioned there are things like Nginx extensions to automatically apply nonces and all that kind of thing. You mentioned they sound like a configuration nightmare, but also I'm thinking if we've got an example of the stored XSS attack, your Nginx is just going to happily sign that for you. So surely it needs to be something that's done at an application level, not...
Yeah. The reason I mention it is because Scott Helm did post an article on how to add the nonce part of a header with Nginx. And I kind of disagree with it because I just don't think it's a good idea to do. I'm of the opinion it should always be at application level because anything that has adding it at an application level should be considered trusted. And again, if that can't be trusted, then you've got other issues that this couldn't necessarily protect against. Your application has got a fundamental fault that can't be fixed. So yeah, I completely agree that you should always add it at an application level. I just mention it because if you Google for this stuff, you might end up finding it, and it's not a great thing to do, in my opinion. So.
Got time for more questions? Anyone?
You want to get to lunch early, don't you?
There is lunch next, to be fair. Okay.
Cool. Thank you very much.
Awesome.
Cheers.